Welcome to week 6, I guess, and in this video we're going to be covering 10.4 to 10.6. Okay, this is the key knowledge from for this lesson, and it was also last lesson's key knowledge, and we're going to be focusing on these 2 dot points. So if you want, you can pause the video at any time if you just want to have a read through it yourself. Okay. For 10.4 and 10.5, you need to be able to draw and name these functional groups. You can read through the study design and you can see how it lines up. I'm really focusing on these points. So you need to be able to, this is about drawing, so you need to draw all of these. In terms of naming, you need to name these. You'll see that there is a difference between drawing and naming. Okay, so in the study design, it's asking you to only draw aldehydes, ketones, and primary amides, where everything else you have to be able to draw and name. So we'll start off with haloalkanes. These are talking about the halogens. The halogens are in group 17 of your periodic table, and you can see that they've got a prefix. So fluoro, chloro, bromo, and iodo. They line up with fluorine, chlorine, bromine, and iodine. And this is group 17 on the periodic table. They're called halogens. And you can see that we've got some examples here. And this is just from your textbook. So the bromomethane, because it's only got one carbon, and we can see where the bromo is. This is 1,1-dichloroethane, so I'm assuming it's got 2 chlorines, and it does. 1-chlorobutane, 2-chloro, 2-fluoro. So here's the fluoro, here's the chlorobutane. Okay, so again, just pause here if you need more time to process this. We'll now move on to alcohols. And in alcohols, we've got primary, secondary, and tertiary alcohols. So here's an example of primary, secondary, and tertiary. Now, in primary alcohols, it's saying that it's only attached to one other carbon. And then it just continues. Dot, dot, dot. In secondary, we've got the alcohol, that the carbon that the OH is attached on is attached to 2 other carbons. So here it's 1 other carbon, and here it's 2 carbons. In tertiary, the carbon that the alcohol is attached onto is attached to 3 other carbons. Just remembering that these carbons also have their own hydrogens. Okay, and now we can just to make it clear, so this carbon, the carbon that the OH is attached onto, is attached to 1 other carbon. In secondary, it's attached to 2 other carbons, and in tertiary, it's attached to 3 carbons. So that carbon that the OH group is attached onto, so 1, 2, 1, 2, 3. And I hope you can see the difference there. You can also look at these examples. So in a primary alcohol, the carbon that the alcohol is attached to one other carbon. In a secondary one, it's attached to 2, and in tertiary, it's attached to 3. Okay, we're going to go on to primary amines. So in primary amines, so it's just the NH2 functional group. So here it is, and these are both primary amines. So this time it's more about the nitrogen. So secondary amine would look like this. Where it's attached to 2 carbons. Where here it's only attached to 1 carbon. So they're both primary amine. And again, you can see that you can look at the naming. So ethanamine, because there are 2 carbons here. So ethan means 2 and butan means 4. Okay, you can pause the video here and you can complete the review questions 10.4 on page 303. Otherwise, you can keep going and do the questions later. So aldehydes. With aldehydes, you only need to know how to draw. You don't have to know how to name it. And you can see that by here it says that you have to be able to draw aldehydes, but it doesn't talk about naming aldehydes. So to draw an aldehyde, it's just the C double bond OH. So this is the functional group, and then it's just bonded to ... any other carbon compound. It's important to note that aldehydes can only be on the terminal carbon. They can't be in the middle of the compound, they always have to be on the end. So in all of these examples, the aldehyde is always at the end. Okay, when it is in the middle, it's called a ketone. So an aldehyde looks like this. A ketone does not have the H. Looks like this. So ketones are always in the middle of a compound. So we can see here it's always in the middle. And to represent it in the skeleton way, an aldehyde would look like this and a ketone would look like this. Okay. Next one is carboxylic acids, and we've covered this last year, so this is just a refresher. And again, carboxylic acids are similar to aldehydes, are always at the end of a compound. It's always on the terminal carbon. And we can see here that the carboxylic acid is always at the end of the compound. Now you need to know how to name these, and to name them, you just always add the oic acid. And you can see that it's ethanoic acid because it's got 2, butanoic acid because it has 4, and then methyl butanoic because it's got a butane group plus the methyl group. Okay, let's just go back and cover what an aldehyde was. So an aldehyde is when it's on the terminal carbon. A ketone is when it's in the middle, and a carboxylic acid is when on the terminal, but it's got an extra oxygen. So just look at the difference between an aldehyde and a carboxylic acid, and you'll notice that it's just this oxygen that's different. Okay, Next one is primary amides. So again, you only need to know how to draw them. You don't have to know how to name them. And primary amides, primary means that it's going to be on the terminal carbon. So again, it's always at the end. You don't need to know how to do a secondary or a tertiary amide, but just for your own interest, a secondary amide, so secondary amide would mean another carbon is attached here, and then the chain goes on. So an amide is just C double bond O, NH2. So where a carboxylic acid is this. I would practice drawing these. There are quite a lot to remember. Okay, and last one is esters. And again, we covered esters last year. And esters, the functional group is really in the middle of the compound. So we can see the esters being in the middle of the compound. And to name esters, the part where it's got the double bond O, so this part, double bond O is always at the end, and we add the OH part. So again, there are 3 carbons here, so it's propanate. 2 carbons here, ethanoate, and where it's not attached to an oxygen, well, it's not double bonded to an oxygen, I guess, we put out the start. So it's ethyl, propyl, propyl. So hopefully you can see why it's ethyl, ethanoate, propyl, propanate, and propyl ethanoate. So again, you can pause the video here and you can do 10.5 questions on page 309. Otherwise, we can continue. So this is just a summary of everything, I guess, and this is going into 10.6, and this is IUPAC nomenclature. IUPAC is almost like it's talking about another language. This is how the world, I guess, labels compounds. So you can see that your textbook has really clearly indicated how they name things. So the bute indicates 4 carbon atoms, because remember, monkeys eat plenty of bananas. So methanol, eth, prop, and bute. The an indicates that it's an alkane. So with this part, remember it's alkane. You can have alkenes and alkynes. So single bond, double bond, triple bond. The 2 indicates the functional group is on the second carbon. So here's the 2, and you can see that the functional group is here. Let me do that in green. And the O indicates the molecule is an alcohol, and you will have different, I guess you'll have different, this is called a suffix, you'll have different suffixes depending on the functional group. So here are all the functional groups that we've covered. And just remember that with aldehydes, ketones, and amides, you only need to know how to draw. So it's actually said here, it's not covered in the course. But for everything else, you need to know the naming conventions. Okay, and sometimes in an amine, you've got 2 different ways of naming. So we can name an amine, but sometimes we use amino, and we'll go through when we use amino and when we use amine. But first, let's just look at some examples. These are isomers of an alcohol with the molecular formula C4H10O, and we can just see how they're isomers. So in this one, in the first one, the functional group is here, in the second one it's here. So immediately I know that this is primary because it's on the terminal carbon. This one's secondary because the carbon is attached to two other carbons. This one's tertiary because there are three. Oh, sorry. Oh no, this is primary because there's only one other carbon. Like similar to this, but it's got a methyl functional group. So that's the addition. Let me do that in another color. And here we've got that same functional group, but OH has changed positions. It's here, and it's actually now tertiary. So we can see how we can have lots of different isomers from the molecular formula. And you need to be able to do this in the exam. Okay. Sometimes you've got multiple functional groups in a molecule, and if you have multiple functional groups, you need to prioritize their naming. And so let's go into the examples. With here, we've got two functional groups. We've got an alcohol and a carboxylic acid. Okay, and here was the alcohol. We've got an alcohol and a carboxy group. We can see that the carboxy group actually has the highest priority, so that's why it is the suffix. And then to say we've got an alcohol, we put hydroxy. But we can see this is priority 1, this is priority 2. With the next one, we've got an alcohol and an amine group. So the alcohol is here, and the amino group is here. So the alcohol takes priority, so that's why it gets to be the suffix. And then the amino is the second priority. Last example, we've got a chloro group and an alcohol group. So a chloro group is a halo group and a hydroxyl group is up here. So hydroxy takes priority, so we can see that ol is the suffix and the chloro is a second. Okay. The amine group is on the fourth carbon, so it's going to be 4-amino. And we have 1, 2, 3, 4, so it's going to be butane. There are no double bonds. So all together, we're just going to do 4-amino butane 2-ol. And that's how we name it. Next example. Let's highlight the functional groups again. So we've got a chloro and we've got an amino group. Now the amino is going to take priority, so we're going to name it amine. So it's on the 1, 2, 3, 4, 5, 6. It's on the first carbon. So we're going to be calling it 1-amine. The chloro is on the 6th carbon, so it's going to be 6-chloro. And we've got 6 carbons in the chain, so it's going to be hexane. We can name it, so 6. I spelled chloro incorrectly. There you go. 6-chloro hexane 1-amine. Okay. Hopefully that makes sense. And lastly, here's your coursework. Watch the Ed Rollo functional groups video and then do these questions. Okay, I'll see you in the next video.